This is lesson 8.1.5. So if you look on Schoology under the School Closure folder for week 12, you'll see just a single page and it has 12 different problems on it. So the goal for today is for you to practice Xbox with these 12. So the instructions for this lesson are to 1, factor each of them using the Xbox method. Or I'm also going to post some links to other videos so you can watch other teachers explain Xbox. Or there's another method called factor by grouping that if you prefer to do that, that's totally fine. You just need to learn how to factor. And then after you finish factoring all 12, you'll notice some of the answers might look similar, some of the products. So what we're going to do after is we're going to group them into groups where the answers are similar. So what I want you to do is go ahead and pause the video. I'm not going to put this on Edpuzzle because there's 12 of them. It's a lot to answer, but pause the video. If you need to, you can copy this down, or if you have a printer at home, you can print out the lesson. So here's the first 6, and then here's the last 6. So I encourage you to do this with maybe a friend or someone else in the class to make sure that you're doing it correctly. Okay, so you should have paused and worked on all 12 of these. So I'm first going to go over how I found the answers to be similar. So the first one I thought was in a group all by itself was letter K. X squared plus 4. Turns out you can't factor it. So if you try to apply Xbox to letter K, you need something that adds to 0 but multiplies to positive 4. So negative 2 and positive 2 will add to 0, but that will multiply to negative 4, not positive 4. So unfortunately, this one's not factorable. This was the only one not factorable. Okay, this next set, you should be looking to see if you can factor out a greatest common factor. Turns out for all of these, they are already factored as the greatest common factor. There is no greatest common factor bigger than 1. So here I have my next group. I would call these the groups where they're able to be factored, but there's nothing in common between the products. So you'll notice here, this is B, E, and I. So you can pause it here if you need to double check your work, but none of these products have any numbers in common. They were able to be factored and they turned out with different numbers. The next group is the difference of squares group. So there actually turned out to be a lot of these, A, F, H, and L. So here in the difference of squares group, every product that you have, it has the same 2 terms, but then the only difference is a plus minus, plus minus, plus minus, plus minus. So again, how you would recognize these is you have 2 terms, there's a subtraction sign between them, and they can be, you can find the square root of each, and the square root of each is a whole number with an x. So you'll notice here in K, the difference was this was a difference of, I'm sorry, it wasn't even a difference, it was a sum of squares. So that didn't fall into difference of squares. So here we have these. Again, you can pause the video to double check your work if you need to. But these are all the difference of squares problems. Okay, and the last set is what we call the perfect square trinomials. So all of these, again, if you tried pulling out a number bigger than 1, you couldn't find one. So for all of these, G, J, D, and C, you look for squares in the front term and the last term, the x squared term and then the term that's just a number. And if both of those are squared, then your middle term is twice the amount of the product of each of these squared. So what do I mean by that? For example, here in J, square root of 4 is 2, square root of 25 is 5. 2 times 5 is 10, and then if you double that, that's 20, so that's the number that you see in the middle. Again, if you didn't recognize these shortcuts, that's totally fine. You can still do Xbox. So I did Xbox for each of them to show that you will still end up with the same answers. But if you're starting to recognize when these are perfect square trinomials, you will see you can save a little bit of time. So I do want to point out that G and C both have negatives. So how we ended up with that, even though this is a positive, is because -3 times -3 will still give you a +9, like you see in the box here. So you need that negative for the -6. Here you'll notice both of them are positive. Actually, all three terms are positive. Same thing with D, all three terms are positive, so there's a plus sign there. So it's 3x plus 2 squared, 3x plus 2 times 3x plus 2. And then lastly in C, there is a negative here too. So if you are feeling good about doing Xbox, that's great. We're going to practice more. In the next few days, you'll have a team test on Thursday, so the instructions for the team test are in the schedule document, but you can work with up to 3 other people on the team test. If you're still feeling a little lost and you're watching the videos that I'm posting and you're watching the extra videos I'm posting and still feel a little lost, let me know. I'll see what I can do to help you with that.